Hello, in this problem you have to convert from degree to radian measure. This is in section 9.1. The conversion factor from degree to radians is pi over 180. So what you need to do is you need to multiply, in this case the 210, by pi over 180, and then we have to reduce. Now your angles in radians need to be written in forms of pi, so we're going to leave the pi, but what we have is 210 over 180 pi, and we're going to reduce. First of all, we're reducing by 10 and crossing out the zeros. Then we have 21 over 18, and in this case 3 is a factor for both of them. 3 goes into 21 7 times, so we're reducing by 3. 7 pi divided by 3 goes into 18 6 times. So here the answer in radiant would be 7 pi over 6. Now let's take a look at another problem. Let's say we have 102 degrees and we wish to change this into radians. Again, we are going to multiply by pi over 180. And that gives us 102 pi over 180. And now we have to reduce. We can definitely reduce by 2. So let's start off small. Divide by 2 is 51 pi over 180. Divide by 2 is 90. Okay, now we're going to look at 51 over 90, and if you take a look at them, 3 goes into both of them, so we divide by 3. 51 divided by 3 is 17. 90 divided by 3 is 30. So we have 17 pi over 30 radians. Let's do one more. How about negative 300 degrees into radians times pi over 180, which is negative 300 pi over 180, and then we're reducing by 10, and we can also reduce 30 over 18 by 6, so 6 is a factor common to both of them. That would be 6 into 30 is 5, negative 5 pi. 6 into 18 is 3, so the answer here is negative 5 pi over 3. And if we're converting from radians to degrees, our conversion rate factor is 180 over pi. So for example, you have 5 pi over 4, and you need to convert this into degrees. You would multiply by 180 divided by pi. So what happens is that first of all, the pi's reduce to 1. We can also reduce further. 4 goes once into 4 and into 180 45 times. And now what we have left is 5 times 45, which in this case is 225 degrees. Let me look at one more. Pi over 2 changed into degrees times 180 divided by pi. We can see that the pi is reduced to 1. 2 goes into 2 ones and into 180 90 times. So pi over 2 is equivalent to 90 degrees. Sometimes we have to convert our degrees into radian measure, and Pearson wants you to type it in as a decimal. So then we have to use a calculator. First of all, we take 46 times pi over 180 as our conversion rate, and then I use my calculator. I type in 46 times pi, which is, oh, my calculator gives me 46 pi. Let's see what happens. Divide by 180 and the decimal, so 46 times pi equals, then divided by 180, I get 0.80285. To list a few decimals, and the computer says, Pearson says, type an integer or a decimal. So that tells you actually have to use your computer. They don't want a fraction here. And round to the nearest hundreds, meaning 2 decimal places. And the next one after 0 is a 2, so that would be 0.80. Okay, with another problem in 9.1, we have 6 radians, and you want to convert this into degrees. So we're multiplying by 180 divided by pi, and this time the answer is to the nearest minute. So we need degrees and then minutes. First of all, 6 times 180, use a calculator, is 1080 divided by pi. You get 343.774677. So I'm going to use all the decimals here because this decimal part I have to convert now into minutes. The 343 is my degrees, and then I'm taking the 0.774677 and multiply this by 60 to get the minutes. 0.774677 times 60. The more decimal places, the better, which is 46.48. So we need this part. Now gives us our minutes. So that would be 343 degrees and 46 minutes. And that's how you convert degrees to radians and radians to degrees.